Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site. And this video presentation is about the 737 head-up display. So I'll be covering the, very brief history of the head-up display, some of the terminology, going through the components, looking at the various Annunciator panels, taking through the Symbology, the modes of operation, byte checking, compatibility with other components, enhanced vision system, synthetic vision, and enhanced flight vision, Minima, and finally a summary of the whole lot. As always, please treat your company training and their manuals as the authoritative source of information. So starting first with the history of the hood, it actually goes back to World War II. They were developed for fighter aircraft initially as simple reflector gun sights, as you see in that photo bottom left down there. Over the decades, more and more data was added to the display, but really they were pretty much exclusively for military use until the 1990s. Now, whilst the military HUD technology was very mature in the 90s, it wasn't ready for civil applications, and the main reason for this was that the role was significantly different. So if you think about what the military required of their HUDs, I mean, first and foremost, what it was designed for was weapon delivery, either as a gun sight or for bomb dropping or whatever it might be. This was what it was all about. Now, incidental to that, it had to have enough data for eyes out operations, give the pilot situational awareness in all attitudes. And later what it would provide would be glide path information primarily for visual approaches with military flying. So if we now overlay this with the civilian HUD requirements, or the requirements in the airline, yeah, sure, there is some overlap. So enough data for eyes out ops, situational awareness, and glide path info for visual approaches. But if you look at the new stuff that the airline requires, it's all about low vis. It's low vis landing and takeoff. That's the crux of it. Now, sure, in recent years, other things have been added on, like tail strike protection, RSAT and TCAS and the likes. But really, low vis is where it's at. That's the main reason for civil HUDs. Certainly not weapon delivery. So the HUD was first certified for the 737 by the FAA in 1994. So I mean, surprisingly long time ago. That's almost 30 years ago now. And this allowed for manually flown Cat 3A landings down to 200 meters RVR, and also takeoffs in 90 meters. The first production HUD was fitted to the first production 737 HUD was fitted to a 737-300 of Morris Air, which was a short-lived airline. It was later bought by Southwest, and that was delivered in 1995. So that was the first one out the blocks. Now, there have been 4 different models of HUD fitted to the 737 over the years. Now, not in chronological order, but just in manufacturer. GEC Marconi did a system known as the HUD 2020, and this was certified in 1999 for the NGs only. So this was never for the classics or indeed the Max. Flight Dynamics, now they were the people that really dominate the 737 HUD market. They started with the HGS 2350. This was certified in 1994 with Morris Air on the previous slide. This was fitted on classics and early BVJs. Rockwell Collins, who Flight Dynamics became, then came out with the HGS 4000 in 1999, and this was really for the NGs. So it's fitted on the NGs, the P8s, and most of the BBJs. They That was superseded by the HGS 6000 in 2017. That's been retrofitted onto some NGs, but really that was designed with the Max in mind. As I said, their flight dynamics was bought by Rockwell Collins, with now Rockwell Aerospace, in 1999, hence the name change. But flight dynamics, Rockwell Collins, Collins Aerospace, it's all the same company. And according to Collins, as of 2017, 78% of the US 737 fleet was equipped with HGS, which is quite an impressive stat. Flight testing of the system. Now, what I'll do is I'll just take you through a brief run through of how Marconi did it, and that's simply because their information is more publicly available. But I'm sure Rockwell Collins went through a very similar process. Now, this started in September '98, and it actually started in a 737-200, and as far as I know, it's probably the only 737-200 ever to have HUD fitted, except possibly the NASA development aircraft. But anyway, they used the 200, and that was simply because there were no 800s available, because in 1998 they were very newly certified and in high demand. So they got done what they could on a 200. There was a 93-hour flight test program on that, which included 170 HUD landings at a whole variety of airports and conditions, and they went up to 35 knot crosswinds at night with no nav aids, and also included a couple of approaches in a major storm, which I don't think they sought out, but just happened to be there, so they took the opportunity to see how it would behave. When that 200 test program was considered to be sufficiently mature, they then transferred onto an 800. This is the one in the photo. It's actually Sabre Airlines of the UK. I think they had a lull in their program or whatever, and they agreed to work with or to let Marconi use the aircraft for a while. And they needed to do the final part of the testing on an NG, in particular an 800, what the initial STC was for, to get the final optimization of the HUD symbology and control laws for the NG. So that's where the control laws come in. So they did over 200 hours in this 800, just shy of 500 HUD approaches, and it was finally signed off in 1999. And the launch customer for this was American Airlines, who I think still operate it today. American had placed the order in early 1998, so it was the year before certification, and that order was for installation on 75 new 737-800s and an option for a further 425 systems. I don't know if they took those options up or not. Perhaps someone from American, if you're watching, you could give us an update on the program. We'd appreciate that. In 2000, Marconi updated the STC to include the whole NG family. I'll say, as far as I know, American's the only 737 operator of this HUD. But again, if you know otherwise, please let me know. All right, so a word about terminology. I'll get this out of the way now, because it can be a little bit confusing. So, head-up display. That is the generic name for any head-up display, or any type or manufacturer, civil or military. So the general name for this system is head-up display, whether you're in your F-16 or your 737 or your World War II fighter aircraft. They are all head-up displays. That's the overarching name. Now within that, you've got subsets. So HGS stands for Head-Up Guidance System. This is the brand name for a HUD made by Flight Dynamics or Rockwell Collins. So a brand name, it's a bit like calling a vacuum cleaner a Hoover, or paper tissues, calling them Kleenex. Okay, so HGS is a brand name, but because it's so dominant in the 737 market, that the terms are often interchanged. The other player, of course, is the Marconi system. They refer to theirs as the Visual Guidance System, so there's VGS. Now, in addition to those, you've got the EVS, which is an Enhanced Vision System. And in enhanced vision, it displays, as the name suggests, an enhanced image of the outside view. So it's not just symbology; it's actually image enhancement of the outside world. You've then got synthetic vision systems, so the SVS, and these are a computer-generated image of the outside world. So that this is not as seen through a camera. This is from a computer database of where stuff is. A bit like having the in a flight simulator. Now, if you combine synthetic vision with enhanced vision, you get what's known as an EFVS, an enhanced flight vision system, as shown down there. So in that particular image, the mountains are synthetic, the trees and the runway and the airport are enhanced. So there you go. That's your glossary of terms. Okay, on to the individual components. So by way of an overview, for this, I'll start right at the bottom for those who may be watching this who haven't flown a HUD aircraft. I know many of you will, sort of out of interest be watching this. This is what it looks like inside. You've got an overhead unit, which all of us who've flown HUD aircraft curse because we bang our head on it. It as you can see, it's quite a chunky thing, and if you're at all tall, then it does kind of get in the way. But anyway, first world problems. So you've got this overhead unit that contains the projector. You've then got the combiner, which is the thing we think of as the HUD, but is only one part of it. That combines the projected display with the outside view. Then, not shown on this picture, you've got a control panel for data entry and to select whatever mode of operation you're using, an annunciator panel, which again is just out of sight on the FO side, and that's all controlled by a dedicated computer, which is in the eBay. There is an option to have dual HUD, so both the captain and the FO have HUDs, but that is really not a common option. I haven't personally seen an aircraft which has got that fit, but I believe they exist. So, starting with the computer, the obligatory in eBay shot from me. That's it. That's there. That's what it looks like. That's actually an HES 6000 because it's only got 3 fault lights on it. You'll find it on the E41 rack of the in eBay. It's got numerous interfaces and inputs from aircraft sensors, which I'll go through in a later slide, and it then outputs the deflection signals and intensity of the flight instrument data and the guidance commands, and electrical power to the overhead unit for projection onto the combiner. Guidance commands on the HUD are calculated either by the HES computer or the flight control computer, depending on which mode is active. And again, I'll come on to that later. So since the computer can compute its own guidance commands and doesn't always simply display the FCS or FCC calculated data, it's got to have its own access to the raw data sensor inputs to make those calculations. So it actually has a feed in from all of that list of components there. So it's nav aids, it's radals, and you get the idea for these. I mean, obviously it can display nav information up there. To certainly display radals, v-speed information, EFVS data, SMIDs for angle of attack, and VSS, the flight control computers for modes and MCP selections. FMC has got a feed into it, which I'll come on to. GPWS for the wind shear option. RA data, so hence your TCAS feed, and the AED IOUs for air data, and also alpha as well. So quite a lot of feeds into this computer. It's quite an advanced piece of kit. This actually is the 4000 because it's got 4 fault lights on the front there. The 6000 is a narrower unit than the 4000, which is again in turn narrower than the 2350, and I say that it's got one less fault light because there's the part interface is done through the McDo rather than a separate control panel. On the first of the Collins HUDs, were the HGS 2350, they had this extra component in the E&E bay called a drive electronic unit. And I say it's probably because of the architecture of the classics EFVS setup that they didn't have DEUs for their EFVS, but instead they had symbol generators. So that's why Flight Dynamics would call this a DEU, I guess. And this is basically there to provide drive to the deflection voltages from the computer to send them to the overhead unit. It contains power supplies for the overhead unit and the combiner. Probably the best way to think of what the DEU is the graphics card. So for those of you that have had a go at making your own computers or speccing them, yeah, the DEU is effectively the graphics card of the system. The overhead unit, this photo, I basically put the camera on the coaming and took back into the flight deck. So that's what it looks like. That's the lens of the overhead unit. For the 2350 and 4000 models, you've got a cathode ray tube in there, which makes the image. That's then projected through a 9-element relay lens. So surprisingly complicated lens setup there, and that focuses the image onto the combiner. For the HGS 6000, which is the latest of the 3 by Collins, the CRT has been replaced with an active matrix LCD design, and the big advantage for that is that it's a lower power draw. So that gives you a benefit, a reduction in benefit in weight, power consumption, and with that lower power consumption also comes an increase in reliability as well. They say it gives a sharper picture quality. Like personally, I can't quite see the difference myself, and improved visibility in bright ambient light conditions, which I would imagine is true, as that's generally the case with LCDs. The overhead unit has actually got a desiccant container in there, which you can't see. Well, all you can see of this is the shroud, but if you remove that shroud, you'll then see the unit. There's a desiccant container underneath that, and that basically prevents moisture from accumulating inside the lens assembly and possibly degrading the image that goes onto the combiner. When you remove the shroud, there's a small viewport under there, and that will show the condition of the desiccant material with a color coding, which surprisingly shows blue as dry and white as saturated. I guess that's a chemical thing, but certainly for most people, blue indicates the sea. Anyway, that's the way they did it. Perhaps would have been helpful if they'd have put a sight hole on the shroud, but maybe in the next model they'll do that. Okay, so onto the combiner itself. That's a very young me, taken I don't know, a good 20 years ago, using the HGS 2350. And what I'm trying to get across in that picture is how the light is reflected or transmitted through the combiner. So the combiner, as the name suggests, it combines the symbols which are projected from the overhead unit with the view through the window. So what you've got is two glass plates there with a wavelength selective mirror layer in between them. It's kind of a one-way wavelength selective mirror, and this will only reflect the green emissions from the overhead unit back to the pilot's eye, and it'll let all the other colours through in both directions. So what you're seeing is green only bounce back from the by the combiner, bounce back from the overhead unit, and this is why this selective mirror nature of it. This is why HUDs are monochrome. They can only work in one very narrow wavelength. I mean, you can choose which wavelength you use, although industry standard is green, but this is why. So there's your money shot. That's what you see. That's the view through the combiner. This particular one's on a Max. I'll go into the Symbology in detail later in the video. There's quite a bit of it, but that's just to give you a sort of a taste of it. Again, for those of you who haven't seen or used the HUD yet. Controls. This again is the old 2350. You've got a lever there to stow the unit. Slightly different use of it on the 4 and 6000, where it's used to release the unit from the stow position. Now you can see that that's potentially quite an impact hazard. This whole unit. So this has been thought out, and in the event of a high G deceleration, that combiner glass will rotate forward toward the windshield to what's known as the breakaway position to minimize head injury. Well, hopefully not cause any head injury at all. The combiner arm then latches it in the breakaway position to prevent it from springing backwards toward the pilot. You can just imagine after you've done an RTO or something worse, this thing flies away toward the window and then comes back and hits you on the head. You'd be most cheesed off about that. So it does actually latch in the breakaway position once it's moved there under G loading. The knob above the release lever, which I've only half got in this photo, that's the brightness control. If the knob's out, then the control brightness is automatic. If you push it in, you can manually adjust the brightness with that knob. On the 4000 and the 6000s, the slightly different arrangement, but it works the same way. You press it in, and you can adjust the brightness as you wish. Leave it out, and it's in automatic mode using an automatic ambient light sensor, which is just on the other side of this unit. You can't quite see it in this photo. There is a small button there inside the hinge. That's the stow switch. This senses when you've stowed away the combiner, and that will then switch off the power to the overhead unit and blank the display. So it's not, it's not heating up, whilst the thing's not in use. Just saves life as well. The early 4000s actually had a problem with display jitter, vibration between M1s. I think it was 50 to 65%. Just a resonant frequency kind of came in and transmitted through, which I never experienced, but I can imagine was extremely annoying. So that was addressed in 2009 by changing the lock-in detemp mechanism from bullnose plunger to a ball type plunger, and by strengthening the combiner arm. They basically increased its thickness where it begins to wrap around the glass. All of that just changed the harmonics and the resonance and got rid of that jitter problem. When not in use, the combiner should be stowed away with its protective soft fabric cover. They are extremely expensive. We're talking many tens of thousands for that combiner, so best not to get it scratched. So in the soft fabric cover when not in use. Okay, what about electrical power? On the P18-2 circuit breaker panel, so that's just behind the captain's right shoulder. This is a photo of an NG with an HGS 4000 and a control panel, and not a McDo, so that's why it's got a control panel circuit breaker at position C2. And it's got a digital annunciator, hence the circuit breaker at C1. There are two 28-volt power inputs, the normal and an alternate. This is for redundancy. The reason for the redundancy is obviously because this could be used, the system could be used during a Cat3 approach. So it needs to have quite a high level of redundancy for Autoland. Well, sorry, not Autoland, for Cat3 operations. The combiner is powered from the overhead unit, which is in turn powered from the HGS computer. So the HGS computer basically channels and directs all the power for all the components. So these are the early control panels. The top one was the very first one used on the 2350. The bottom one's the one from the 4000. They are pretty much identical, certainly identical in function. The only difference really, and the only reason I put them on there is just to show you the branding. The top one's branded Flight Dynamics, and the bottom one Flight Dynamics in Collins. The bottom one there shows you input the data for landing. You got the runway length in there and a glide slope angle here shown as 3 degrees. There's no PC setting to switch between feet or meters on this panel, so you can have whichever your airline prefers. And of interest, 4 of the keys, runway, glide slope, clear and test, have got LED annunciators to indicate that they are engaged. So that's your control panels there, and they're in the central electric panel between the radios on that panel. The GC Marconi, that's shown right, and the HGS 4000s, and of course the 6000s, they're programmed from the McDo. To access the HUD controls, you simply press the menu key and then select HGS, and that'll take you through to the HGS pages in the FMC there. So the one it'll take you to first would be the data page, and on this you would enter the runway length, elevation and glide slope angle for the approach. So it's the same data that you would have put in on the old control panel that I showed you a couple of slides ago, but it's now done through the through the CDU, or the McDo. From FMC update 10.4, the data was automatically populated from the arrival which you programmed in the FMC, so that was very handy and useful. The one thing I will point out is when the data is pre-populated by the FMC, it shows up in small font as per the upper photo. If you've either manually entered the data, or you've hardened each field by double pressing each key, then they will show up in large font. And of course, it's good practice to go through this, as a crew before shooting the approach, just to confirm that the data is correct from the FMC. I guess one thing worth mentioning is that if you've got an HCP, so the HUD control panel, instead of the McDo FMC data, there is only one font size on the control panel, so you can't see whether that data was manually or automatically entered. So just a little gotcha there for crew procedures. Okay, on to the Annunciator panels now. That's it in the photo way over there on the right hand side. This is this is on an old 2350 on an aircraft I used to fly. The Annunciator panel, it's always located on the FO side of the instrument panel. That's to enable him to monitor the modes and warnings whilst the captain's looking, his eyes out through the HUD. There have been several types of Annunciator panels, actually 4 different types, and this was the very first one, and it's what's known as a 3-element panel. I say it was used on the 2350. So that's what it looks like in large. So you basically got 3 different captions on there. You've got A3 in green, which just to tell you that the A3 mode's active and that all the required systems and equipment are valid. Approach warn in in red. It hasn't the colour hasn't shown very well on here. Indicates that either the system or approach conditions are out of tolerance. So much like any amber stroke red warning on an approach, you'd certainly consider going around if you weren't happy with visual references. And the bottom one is flare, which in green just simply indicates that the flare portion of the guidance is active. So it is showing flare. This was superseded on later 2350s and early 4000s with this 6 panel. Discrete panel, and it added 3 annunciations for rollout. So the bottom row there is all about rollout. You got rollout arm in white, like most ARM modes. So it basically tells you that rollout will be available. Rollout caution in amber indicates a loss of rollout capability below 500 feet. And rollout green indicates that rollout is actually active. You also get that on the combiner as well. That was replaced on later 4000s and the 6000s on the NG with this display, and so you've got things like the out to the right there you've got the HGS fail button. So you got the computer's actually failed in comms during an A3 approach below 500 feet. So again, big red lights in 500 feet on approach. Consider whether you want to be there or not, and going around. No A3 amber indicates the loss of A3 capability above 500 feet. So it's amber above 500 feet and red below 500 feet, and the flaring green there. So that's flare active. Takeoff annunciations it has 3 of them. Takeoff in green, takeoff caution in amber, and takeoff warning in red. Now, as far as I know, they were built into this panel to support these takeoff functions, but were never used. They do show up on a light test, but I stand to be corrected, but I don't think those features were ever used. And then on the Macs, you've got basically the MDS version of the previous display. This is located at the top of the FO's auxiliary display, and it's got all the same messages from the previous panel, plus additional ones depending on what options you got selected, like tail strike or what have you. So that's that there. Okay, onto the obligatory schematic. So, summary of the components. It all starts with the HGS computer buried away in the E&E bay. That's it there. This is powered by DC bus 1 and 2 for redundancy. You've got your circuit breaker panel over there on the P18-2. It gets inputs from that long list of aircraft sensors, and also inputs from the control panel or from the McDo. So you get your pilot inputs there. Outputs are through to the overhead unit. On the 2350 system, which was remember designed for the EFVS Classics, you've got an extra DEU or graphics card for the display. The image is projected onto the combiner, which is what we see. And if we need telling anything about the status from the computer, the Annunciator panels are there in their various forms. So that's the summary of the components and how it all fits together. The various versions I've just summarized in this table here. The dates of certification, so you've got 2350 in 94, 4000 in 99, the 6000 2017. The Marconi one actually came in 1999. The type certified, whether you got a dedicated DEU, blah 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 blah. So that's just a quick reference guide for all of the various systems. The only one I'm not familiar with because I've never flown it was the GC Marconi 2020. I don't know what they have in the way of an Annunciator panel. I'm sure they have one. I'm sure it's similar, but slightly different to the Collins one. But I haven't seen it. Again, any of you out there flying this aircraft, send me a photo of the Annunciator panel. For that, I would really appreciate it. All right, onto the Symbology. So this is the interesting bit for us as crew. This is the HUD in primary mode. This is the everyday working mode, the mode that you've got 90% of the time. What I've got here is I've got both the HUD showing in the top of the photo and the PFD and top of the ND showing the bottom of the photo for comparison, so you can see what's going on. The main difference between the HUD and the PFD ND displays is that the HUD's monochrome green, as previously mentioned, because that's the only way the combiner can work. So that means for us that no color coding can be shown, and I think this photo here really shows that in stark contrast, the myriad of colors on the PFD versus monochrome green on the head-up display. So it does make the display a bit more confusing because there's no possible use of color. And I would say that the only way around this is really, the confusion is familiarity. So those airlines which tend to use the HUDs a lot, I think are probably probably better placed for their crew to be able to find the information quickly, because as always when adjusting to a new display, the main issue is not the lack of information but finding it on a busy display. Okay, so looking at these things individually, the speed and altitude tapes, I say monochrome versions of those shown on the PFD, but otherwise the same. The vertical speed tape on the PFD isn't actually displayed on the HUD. Well, what they've done is they've just replaced that with a digital VS shown there. Note that in VMC, IMC and A3 modes, vertical speed is actually brought in toward the center of the display near the flight path symbol. That's actually true of various other things as well, like altitude and speed. The flight mode enunciations are all shown in a row across the top, just like on the classic PFD. So you don't have command, in the sort of lower center as you do on the NG and the Max. It's gone right back to the classic arrangement there. FMAs are still boxed when they changed, as you can see on there on MCP speed and altitude acquire. Active modes are shown above a line and ARM modes below the line. So heading select that you can see there is active. The pitch scale, it's shown in 5-degree increments, and it'll go from -20 degrees all the way up to +25 degrees. 0 degrees is the horizon line, which is that's the solid line up there, and that simply shows the horizon relative to the aircraft reference symbol. So you can see that here that the aircraft's pointing slightly below the horizon because we're in a descent. The aircraft reference, this is why I hesitated a moment ago when I said the aircraft is pointing. We've got to be really clear about what we mean with this terminology. So let's go through those steps now. So this is the aircraft reference, also known as the bore sight. So the top center of this symbol represents the aircraft projected center line. So this is where the physical body of the aircraft is pointing. So that's slightly nose up, 2.5 degrees nose up above the horizon. That doesn't mean to say that's where the aircraft's going. That's just where the aircraft's pointing. Now this symbol's always positioned 7 degrees above the display's vertical center, regardless of whether you're climbing or descending. And it's fixed at the display center. When the usual attitude display is active. So there you go. So that's it. Now, if I now show the flight path vector, this is where the aircraft is traveling. Okay, so it's pointing above the horizon with the bore sight 2.5 degrees nose up. That's your deck angle above, but the aircraft is traveling below the horizon. It's descending. It's in a 2.5 degree flight path descent here. This symbol's got display priority over all other symbols except the guidance cue and the flare command, because this is the one that's of most importance. And you will find when you use the HUD that your focus is all on this. To the extent that you have to be a little bit careful about not getting tunnel vision or target fixation on this. You know, the rest of the information is there, but this is where the concentration is. This is computed by the HDS computer, so it's not the same source, the flight directors, and it's considered to be more accurate and sensitive than a flight director. The flight director guidance cue is this circle inside that flight path vector. That is effectively your flight director for the HUD. You pitch your roll to keep toward the guidance cue to keep that circle inside the flight path vector circle. And I'll say that's where you can get a bit target fixated on this. During the A3 mode, as I say, it's generated by the HGS computer, not the flight control computer, for increased accuracy. And the only other thing to mention about this is that it will change to a solid circle in wind shear, as shown on that inset photo below. So that's your flight director right there. Just to the right of the flight path vector, you've got your flight path acceleration, or otherwise known as the inertia caret. And this indicates the sum of all the forces affecting the aircraft, such as thrust, drag, and wind. And basically how this works is if it's positioned above the flight path vector, then it shows the aircraft's accelerating. If it's below, then the aircraft's decelerating. Now here it's lined up exactly with the wing of the flight path vector, so there's no acceleration there, and that you can get confirmation of with that there's no speed trend error on the speed tape. The only time that isn't displayed is when you get a decreasing performance at low level wind shear below 400 feet AGL, but effectively 99.99% of the time that is there. Now that shows you whether you're basically accelerating or decelerating. So quite useful for your energy information. The fast slow indicator, now on this, the photo on the right, which is the one I've been using for the last several slides, it actually doesn't show because you're on target speed, as you can see from the speed tape. So if you look at the inset photo on the lower left, that gives a better example of this in use. So you get a bar appearing above or below the line on the flight path vector that shows whether you are above or below target speed, and the size of the line, or length of the line, it shows the magnitude of the speed deviation. Now when the length of that line is the same diameter as the flight path circle, that shows that you're 5 knots, well, fast if it's above, or slow if it's below. So in that inset example, you can see that it's a little bit more than the diameter of the flight path circle. So that's about, I don't know, 6-7 knots fast. But your inertia carrot, your acceleration thing is below that, so it shows that you're decelerating. So you're in that inset photo, you're a little bit fast, but you're decelerating. So you're correcting nicely. On the main photo, you can see that there's just slight. The line is very, very slightly below. I mean, you're talking a fraction of a knot slow, which is more accurate than most of us can fly, certainly me. So a couple more examples of this, but using the two together. So using the fast slow indicator together with the inertia carrot, it does give a lot of useful energy information. So on the left hand photo is the one that we've just been looking at. So you're holding on target speed there. On the upper right photo, you're holding slightly below target speed. So it's showing that you're about, what, 3-4 knots slow. But you're neither accelerating nor decelerating. And on the lower picture, you're what's that, 4 or 5 knots fast, but decelerating. So that's how to use those together in combination. The bank scale and pointers up there at the top central display shows the angle of bank in 10-degree increments from 30 left to right. Tick marks will be added at 45 and 60 if your angle of bank exceeds 35 and 50 degrees respectively. And the bottom of that triangle is the slip skid indicator, same as the one that you've got on the PFD. Track and heading now. This is arguably where it gets complicated. It's shown in several places on the HUD. And again, if you look back at the reference to the nav display there, so you can see that the heading there is 110 or 111 as is shown on the nav display. That is your actual heading. Heading spelt out HDG 110 is the selected heading, and that's shown down there on the bottom left. So obviously this picture was taken in heading select, so your selected heading is 110. And you look, you can see the track there of 111 just slightly off because there's a tiny bit of drift on. The wind vector is similar to the one shown on the nav display, but it only shows the wind speed on there. It doesn't show the direction. Again, I think this is all to do with trying to declutter the head-up display. It's a fine line between putting enough information on and putting too much information on. If you think about it, the wind vector isn't actually on the PFD. It's on the ND, so you're almost trying to combine more onto this display than is on the PFD. So that's got to be done carefully so you don't overload with too much information. Ground speeds down there. Again, this is an ND information thing. So again, just as I was saying a moment ago, you've got to be familiar with the display and the location of the information. It's not that the information isn't there, it's where to find it. So ground speed displayed at the bottom of the speed tape, run next to the wind arrow. TAS is not displayed on the HUD. Rod 8 and nav aids are shown down there for the VOR and the ADF pointers. They're shown on the compass rose. Selector course is in there in the field below the selected heading. So here it's 022. The upward arrow below the horizon line, which is shown at heading 102, is the selector course. Now that's what we call ghosted. So it means it's off scale. So it's just parked at the left, on the side which is closest to the selected course. I'll mention ghosting in a moment with a couple of other examples. Distance to go is down there as well, 15.1 nautical miles to your next waypoint. So that will be normally shown top right of the ND, but it's just out of shot in this photo. And alpha, your angle of attack, is up there on the upper right. Now, whilst this is optional on PFDs, it's actually standard on HUDs, on all HUDs. So it displays the current angle of attack and the stick shaker trip point, which is where the triangle is. The only thing to add to that is that on approach, there's what's known as an approach reference band. This will appear after your landing flap is selected, and it indicates the safe range of approach angle of attacks for a VREF whatever flap it is that you're landing with, plus 5 knots on approach. So that's the approach reference band there. You've also got an additional display on here, which is that sort of large square shaped bracket. That's your angle of attack limit indication, and that's positioned above the flight path vector when you get within 5 degrees alpha of stick shaker, or when the wind shear mode is active. And it shows your margin from the stick shaker by descending toward the FPV the closer you get to the stick shaker angle of attack. So that will start to descend towards that FPV as you get closer there. I don't know why it's visible in this photo, because the margins appear to be absolutely fine, but I can only think that perhaps there was a little bit of turbulence at the time, but who knows. All right, ghosting. I mentioned it earlier, but I've got a couple of examples on screen here, and a slight difference in display when ghosting occurs. So what ghosting is? It's when a parameter is beyond the full scale deflection, but it's still displayed on the HUD. Now there are actually 2 ghosts in this photo. The first one is the FPV. Now you see it's in dotted lines. It's dashed. That's the indication to you that it's ghosted, and that's because the drift has pushed the track to 227 according to the drift angle pointer to the edge of the horizon line scale. So it's not off by much. It's probably parked there at about 228, 229. But whereas 227 is the actual track, but what it's telling you is that it can't accurately represent on that horizon line where it's supposed to be, because it's beyond the scale. So it's dotted it. The course arrow is the other one, the same as in the previous example. Selected course is actually 039. As you can see from the bottom left of that display. It's beyond the horizon scale to the right, hence it's shown ghosted near the right hand side. So it goes toward the closer side of the horizon line to where it's off scale from. So there you go, that's ghosts. Who knew? The takeoff rotation cue is the next one I'll show you, and now this is only displayed, well, A, when you've got that option installed on your aircraft, but B, when you've got an ILS selected on for the takeoff runway. So if there's no ILS selected, then the low-vis takeoff display will not be available, but other symbols are. So your takeoff rotation cue is there. That's those large brackets. At rotate speed, that cue will rise, and you've got to rotate to keep the aircraft reference symbol centered vertically within that takeoff rotation cue. You've also got the toga target pitch line. That's displayed whenever toga mode is engaged until the mode is exited, and also obviously you got it here for a normal takeoff. So you got a horizontal dash line and it starts off at the top of the display. As your pitch attitude increases during the rotation, that target pitch line moves vertically in response to the pitch command from the flight director. You just need to pitch to keep the aircraft reference symbol over that target pitch line. The flight director guidance cue is shown whenever the aircraft reference symbol is within 2 degrees of that target pitch line. Okay, enough of symbology. Let's have a look at modes. There are 4 available ones. Primary, as I've already mentioned, that's the main takeoff and en route mode. IMC mode you'd use for the autopilot flight director approaches. VMC is used for visual or circling approaches, and A3 is for Cat 2, Cat 3A approaches. You select them either from the panel or from the McDo. Primary mode. This is the common one. This is the one you use all the time. It's the only mode which never indicates itself up at the top right, at top left, sorry, of the HUD display, presumably because it's the default mode. So it's actually adding no information, useful information, because it assumes that's the mode you're in. It's the only mode which displays the airspeed and altitude tapes as well. That's just what it looks like on the original 2350. Low-vis takeoff mode. This is actually displayed via the primary mode, so it's a subset of primary mode. It uses the vertical ground localizer line below the ground roll reference, which I've drawn on there. I don't normally Photoshop photos. I always avoid doing it, but I didn't have a photo of it, and I wanted to show you it. So that's it there inside the red box. That's your vertical ground localizer line. Low-vis takeoffs and A3 use the, as a reminder, they use the HES computer for guidance commands, not the flight control computer for increased accuracy. For a low-vis takeoff, you have to enter the ILS frequency and course to the takeoff runway. That's in addition to your normal data that you put in for a reland. Verify the alignment in the IMC or VMC modes, and then select the primary mode. But again, it'll all be there in your company SOPs for how to do this. But that's what it looks like. VMC mode. This is really only used for visual and circling approaches. You'd never normally use it at flight level 350 as it was here. Again, I was just grabbing a photo of VMC mode to show you what it was like. Probably not ideal to be taking photos on a circling approach, so this is the best I've got for the time being. It's particularly useful for runways without PAPIs, or obviously without glide slopes. Also runways with poor lighting or at night. And it allows the pilot to construct a visual glide slope to the runway touchdown point. So you in the FMC actually you program within the runway whatever slope you like, obviously normally 3 degrees, and this will give you that and guide you down. You can see the 3 degree dash line there below the horizon line. In VMC mode, no guidance commands are given. The combiner displays limited information, as you can see, and the primary benefit of it is that the desired glide path can be accurately flown without reference to ground-based landing aids. In other words, it paints on a 3 degree line for you. IMC mode. This is used for autopilot flight direct approaches. In other words, non-precision approaches. So LNAV, VNAV approaches. Or RNAV, whatever terminology you wish to use. It gives nav guidance from the flight control computer. So this is the slightly less accurate version. I mean, it's accurate enough, you know. It's what we use on non-HUD aircraft, so it's still pretty accurate. and it displays it as a flight director command. This basically allows flight director approaches to be flown using the same combined display format as the A3 mode. So again, this is the whole thing. Comes back to IAN and other similar look-alike approaches. If they all look like an ILS, then we're all going to be familiar with them, and we're all going to be able to fly them hopefully with the same degree of accuracy. One thing to point out on here is that sort of diagonal row of dotted lines. That's your extended centerline, and this is a part of the perspective runway or RSAT package. So perspective runway, you can see the enunciation. I haven't highlighted it, but up at the top left of the display, you can see you've got an enunciation PRWY, perspective runway, that is. This is an optional extra. So in this photo you can see several elements of that extended centerline. If you need to know, they're spaced at 1438 feet or 438 meter intervals. I don't know why they chose such an odd number. You'd think they'd go for around half a kilometer or something, but anyway, that's what they are, and that will come into view when you're within 25 miles of the runway, and it also starts to fade out again as you approach minimums. The A3 mode is designed for manually flown ILS or GLS approaches right the way down to Cat 2 or Cat 3A minima. Now, as you can imagine, that demands a very high level of accuracy, and of course we've all flown the aircraft on the flight director and know that at times that can be a little bit off. In fact, at times you can actually see a disagreement between the left hand and the right hand flight directors. I'm sure we've all noticed that from time to time. That can't be allowed to happen when you're hand flying to Cat 3 minima. So the guidance, the flight director guidance is actually generated independently within the HGS computer, and it generates guidance which is of a greater degree of precision to the flight directors that we're used to seeing on the PFD. Ops procedure for this is to verify the A3 mode is active at glide slope capture. Again, refer to your FCOMs and your company procedures for that. Again, like in IMC and VMC modes, the speed and altitude tapes have been removed and the information condensed down to digital format, brought near to the center of the scan. So the speed and altitude are right there near the flight path vector. So with regards to speed, you can see the bug speed is actually 146, which you can see above the horizon line. The actual speed there is 152, so it's holding 6 knots fast. That, of course, is echoed by the speed bar on the above the flight path vector line. Remember, I said it was 5 knots for a diameter of the circle, slightly bigger than the diameter of the circle. That's your 6 knots. But the caret there is showing slightly below, so you're decelerating. So that's coming back nicely towards 146 knots. The actual altitude, 1080 bar ref, and vertical speed, 700 feet per minute, are also shown, brought in toward the center of displays. The 710 in the middle at the bottom there, that's the rad alt. So obviously you can work out the elevation from the difference between that and the baro altitude there. Perspective runway, yes, sorry, I think I spoke about this on the previous slide, but anyway, that green outline around the runway there, that is the perspective runway as part of the optional RSAT package. Whenever perspective runway is available and active, then you'll get the P runway enunciation up at the top left. It's a little bit difficult to see. It's a tiny bit cluttered, I guess, right in the center. But as you get closer, then that runway, starts to loom large, and it's outlined there nicely for you. Again, it was all getting so busy, I needed to zoom in for this one. So this is the previous picture, but zoomed in, and what I'm highlighting there is the ILS deviation display. So the raw data deviation is shown with a cross near the flight path group at the centre of the display. So you can see that. And it is hard to see, but you're just very slightly left of the localizer. I mean, not much, not that you get pulled up on, but just to show you the slight deviation there. Now remember that this cross is a deviation, not a flight director command. So it's not necessarily telling you, how much to fly left or right or up or down. It's just showing you that you are slightly left or right or up or down of the beams. A3 mode rollout is shown on there. So if the rollout mode option is enabled in your config, then the HGS changes to rollout mode at touchdown. If it's not enabled, then i.e. if your airline hasn't got this option, then the HGS will just stay in A3 mode during rollout with no rollout guidance. So if you don't already know, check your FCOMs to see whether you've got rollout mode or not. Again, just to recap or to summarize which modes are the guidance sources from. So for low-vis takeoff, A3 and rollout, the guidance source is the super accurate one generated from the HGS. Primary IMC are both generated from the flight control computer, and of course VMC, you don't have any. You've just got a 3-degree line below, or whatever degree you want for your visual or circling approaches. All right, bike checking. Slight change of gear now into the maintenance side of things. If you go to your HGS data page, you will notice that there's an HGS test selection available there. This is only available on the ground, as is the case with all the maintenance functions. So pressing that test prompt, line select 6 right from data, will take you to that HGS test page shown there. Now, uniquely, the test pages actually don't show up on the McDo. They show up on the combiner of the HUD, which is what that photo on the right is showing. There is a cursor there, which you can see, which is at the top of that list, aligned there with top level part numbers, and you move that cursor up or down with the scroll up and scroll down buttons on the McDo, and when you find you want the one you want, you hit it with select, and then it takes you to the next menu. And again, the menus and the pages all appear on the HUD combiner. I don't know why they did it this way. I'd have thought it would have been easier to work on the McDo personally, but there we go. That's how they've done it. This photo just shows the test mode. So, and there are all kinds of tests available from the control panel. A fast check operational test, a complete system test, control panel test, the HUD computer and combiner tests, and the Annunciator panel tests. All kinds of tests. The GC Marconi 2020 HUD, that's got a slightly different menu, and on that it shows both test and maintenance on the same page, which is there. Okay, that's enough of my testing. Quick word about compatibility. This is probably for the tech captains and fleet managers out there. This is stuff you kind of need to be aware of, but So as we've already seen that there are three different types of Collins HUDs. Now, let's forget Marconi for a minute because they're just out there. But for the Collins, you've got the 2350, the 4000, and the 6000. There are also different options and update levels within that, known as phases, within each series. And it's in a similar way to the FMC and actually other components have got software to run them, and that software is updated, periodically, and new functions introduced and new features and new options become available. I say the one we're most familiar with as pilots is the FMC update. Update 12, update 13, 13.1, 14, whatever it might be. But the HGS system has also got its own updates, and the current one is number 6, known as Phase 6. And to give you an idea of the features that were introduced with Phase 6, and I say I'm not going to go through all the phases, but just so you can get an idea of what kind of things are introduced with each phase. Phase 6 included 3.6 degree glide slope approach capability in A3 mode, takeoff rotation queuing, display consistency algorithm updates. That's a sort of behind the scenes thing. Landing tail strike warning update, which is useful. The partial compass rows or the compass rows was partially decluttered. Runway remaining available for all approaches, and a graphical braking scale. So they're gradually introducing more and more features and functionality into the HUD, which of course you've got to be careful that you don't make it too busy. But these are all useful safety features. So these functions are all embedded into the OPS, the operating software, and the option to enable them, because just because you've got Phase 6 doesn't mean to say you've necessarily, to be frank, paid for the optional extras. They're all contained in the OPC database, which is the Operation Program Config database. And if you look at the image on the right, this is from one of the maintenance pages, and it shows you the operating program software part number there. That's the part number for Phase 6. The OPC, i.e. what options you've got selected, and the hardware, i.e. which HUD it is you've got. In this case it was the HGS 4000. So I've mentioned the options, the OPC. This is a list of possible OPC selections for the 6000, and I know the image shows the 4000, but it's all the same really. So it's this divided into three groups. You've got hardware options, which is whether you're single or dual FMS aircraft, whether you've got no ADFs, one ADF or two ADFs installed, whether you've got a separate auto throttle computer installed, or whether it's the auto throttle, which is part of the FCC. Display options and modes are all there. Now these are the things which we as pilots get to see. So this is the meat of it for us. Whether you got a digital HAP or not, whether you got A3 mode enabled. I mean, I can't imagine why people would ever not have it enabled, but because that's surely the reason why you have a HUD. But anyway, the option is there. Ground deceleration scale symbology enabled. That would be a nice feature. But again, your airline, your flight ops department would have to pay for that. Tail strike avoidance symbology, runway length displayed in meters or feet, ground localized deviation, A3 rollout guidance, alpha symbology, but that is standard. ARM flight director modes, flashing altitude miscompare, expanded radar display, inhibitor of single channel enunciation, McDo HGS data input, perspective runway. So there you display the various options and modes. So again, don't think because you've either flown a HUD with one airline, you go to another airline, it's going to be the same, or even different aircraft within the same fleet. each aircraft has to be configured individually, and hopefully your airliner's got the whole fleet configured the same. Future use items include GLS for low vis takeoff and approach, and A3 with Land 2 and Land 3. So there's your list of options. All right. A word about DEUs. I've already touched on this with the 2350, which has obviously got to have that extra DEU box in it because it is from the old classics. Now this is more talking about DEUs with the NGs. So what I've written here is that although not directly connected to the HGS, it's important to understand the DEUs. Well, they're known as the MDS, the display processing computers on the Macs, because of compatibility problems. Now, on the NG, the PFD and ND displays are driven by the DEUs. You've got to think of this, as I've said before, as the graphics card of your PC. The original DEU, which was known as the Mark I hardware, part number 930, was updated to DEU Mark II, part number 940 in 2008, and they are actually intermixable. And that photo on the bottom right in the E&E bay shows an NG which had a DEU Mark I, the DEU Mark II installed, intermixed. It's not common. I presume one of them failed and it was replaced with a Mark II. But I guess that means that if one fails, you don't have to go to the expense of replacing both with Mark IIs if the Mark I is obsolete. Anywho, because these are computers, they've got their own operating software, just like the HGS has, and just like your FMC has, and just like so many other components have. These are known as block points for DEUs, and in my book I've got a full list of all of the block point features. Now these softwares are also updated and have different optional features, just like we were looking previously at all the software and optional features with the HGS Phase 5. Now we're talking about the DEUs and their software and their options. There are different features which you can enable or otherwise to enable different display functions on the PFD and the ND. And the latest is Blockpoint 2015 Alpha. Why am I mentioning this? Because of compatibility problems, and this is where the headache begins for those of you in the fleet office or maintenance. So I think I've phrased it quite well in my text here. So for reasons which possibly only computer or electronic experts understand, so it's way beyond my knowledge, the version of the DEU, its software and the FMC update all have an effect on the performance, or more accurately the non-performance of the HUD. And here are just some examples, and there are more than this list, trust me. The HGS 2350, the first one, is not compatible with CDS Blockpoint 15 or 15 Alpha. Aircraft with a DEU1 installed and CDS Blockpoint 06 or earlier had blanking and flickering issues when the FMC was updated to update 12 or later. Now you can upgrade to CDS Blockpoint 15 or 15A, which takes care of that problem, but that is then not compatible with the HGS 2350. So if you want to update your FMC to update 12, you can't use HGS 2350. And also aircraft with DEU2 installed can handle update 12 or later, but for HGS 4000 you need Phase 6 software to support the new data rates implemented in the CDS Blockpoint 2015 software. So compatibility is a nightmare, and doing something as simple and as seemingly unrelated as updating your FMC software can have huge implications if you've got a HUD and you're not sure what the DEU models are in eBay. So there you go. Some things to bear in mind before updating various parts of your aircraft. RSAT or RCAS, these are two options which are also available on the HUD. So you got your Boeing runway situational awareness tools, the RSAT, and the roll command alerting system functionality. So RSAT. Now, a lot of the photos I've shown you before were of an aircraft which had this feature, so you'll have seen some of these features on the previous photos. So speed brake warning, actually that wasn't on. Control wheel steering mode enunciations, that wasn't on, because who uses CWS these days? The Boeing HUD symbol update from a gull wing to a straight wing, well, that was on, you saw that. Perspective runway symbology, you saw. In-air overrun warning and on-ground overrun warning. And for RCAS, which is the roll command alerting system, you've got enhanced bank angle warning and autopilot roll saturation alert. So those are extra features which are coming or in place. Okay, now the next big development was EVS, Enhanced Vision System, and this is a really sexy feature to add on to HUDs. So before I get on to what it really looks like, this image, I need to explain this image. This was not low-level flying. This was the aircraft parked on the ground, and this is a view of the lower DU on an NG showing EVS, the Enhanced Vision System. So, theory of EVS. EVS works by using an infrared camera mounted on the nose to detect the heat radiated by objects, by everything, anything in its view will reflect heat. Now how this works is that the difference in heat signatures of different materials on the ground gives the contrast. And probably the best example is a runway. Now, a runway is made of, I don't know, concrete or tarmac or whatever, some sort of, hard mineral that absorbs heat and then re-radiates it back out. It's got a certain specific heat capacity. The grass next to the runway, between the grass and the soil beneath it, that absorbs the heat but doesn't reflect it out very well. It's got a large specific heat capacity. The tarmac and the concrete of the runway's got a small specific heat capacity. And an example for this is, I don't know, if in your garden you've got a patio, if you put your hand over the patio on a warm day, you will feel the heat off it, or off a brick wall or anything. On a warm day, you will feel the heat coming off that. If you put your hand over grass or soil, you will not feel that, because it does not give that heat back. So that's a big example a big and obvious example you can kind of do at home. Now that is what the EVS is looking for. It's looking for this re-radiated heat off objects. And the contrast in that re-radiated heat is what you see on the display. So if you look at this picture, the buildings, the concrete, the van, the fence, they're made of hard things. They're made of brick and metal, and they are re-radiating all that heat. The sky is made of air. That does not re-radiate heat very well, because it hasn't got the heat capacity. The trees are the same, and I say that each thing has got a different heat signature, a different specific heat capacity, and that is the difference that it's picking up. So it's not looking at visual light, It's not a camera in the conventional sense. It's an infrared camera. So EVS, it works well in absolute darkness. Actually works well in hot or cold temperatures, and most weather conditions. But what it doesn't work well in is if there's a high moisture content in the air. Water particles absorb and block the heat, so dense fog or heavy precipitation will reduce the picture quality. So let's see it in action. That's it. The picture, the upper picture is with EVS switched off, and the bottom picture is with EVS switched on. Now this was up at 18,500 feet, so it's all you've really got on the EVS image there is the terrain. I will show you better images later of the runways and the approaches. But what happens is that the infrared camera information passes its data to the HGS computer. The computer then adds the information to the normal HGS Symbology and sends those signals to the overhead unit to be displayed on the combiner. The manufacturer states that EVS display is not to be used at any time as an aid to navigation or otherwise for guiding or maneuvering the aircraft in flight or on the ground. So what it's really this is I was just about to use an impolite phrase there, but basically they're covering themselves. They don't want you, not that you would, go flying through the valleys just on the EVS camera, like the military boys do with night vision goggles. This is not MVGs, okay? And they don't want you taxiing around things at night in a poorly lit environment, relying on the EVS camera not to hit the, I don't know, whatever it might be. So it has limitations. I mean, I'm sure it could be capable of being used for both of the aforementioned functions, but the manufacturers are washing their hands of it. So it's just to enhance situational awareness. It's, as I say, it's not for doing low-level navs or for taxiing around obstacles at night without suitable lighting. Okay, as we've already seen, the EVS display can also be displayed on the lower DU, and in actual fact this was the way it was first done. This is done really for verifying EVS availability and for enhanced obstacle awareness during taxiing. So you wouldn't normally have it on in flight, but anyway, there it is. Note that there are no HUD symbols on the lower DU, it's just the raw EVS image. And you would select it on with the selection box there. So it's on the central electronics panel. The in-off positions are the ones you use for your CCTV cameras, you know, for the galley area just behind the flight deck door. So that's head down. Now, going back to the 737-200, this actually. There were some 737-200 VIP aircraft, which was the forerunner of the BBJ, that had EVS installed. Now they didn't have a HUD, so it was all head down displayed on the multifunction display. The camera was actually mounted between the radome and the nose wheel well, as you can see in these photos. And unfortunately, that distance between the camera and the pilot's eye line did give problems with parallax, and it was actually quite notable when taxiing. The display was, as I say, displayed there, and that this was taken from a real 737-200 VIP, and this was a fit installed by Universal Avionics. Just to prove it was on a 200. There you go, that's definitely a 200. It's got EPA gauges and everything, and you can see those two buttons there, which show EVS on and off on the right and EVS zoom on the left. So for the NG, there was EVS was introduced in 2006 as an upgrade to the HES 4000 system. It was first installed on a BBJ in 2009 with the STC issued in 2010, and it's described as a supplementary display of primary flight information for situational awareness. An operational credit for reduced minima due to the EVS was not approved. It requires phased 5.2 software or later, and it isn't available as a retrofit onto the 2350. So it's just for the 4000 and the 6000 systems. The latest one is now known as the EVS 3600, and this has been certified for use on the HES 4000 in 2017. So that's around about the time the Max came in. In March 2020, so it was certified for use with the 6000, and in May 2022, so this is hot off the press, only a couple of months ago, Collins announced that the Bahrain-based airline Texel will be the first airline to receive this new combination. So it is actually just starting to appear on the streets now. It uses, according to their info, multispectral camera imaging, including multiple near-infrared visible light cameras and millimeter wave radar to give a head-up view that exceeds natural vision. And as you can see from the press release photo there, it is a pretty good image. When you think that potentially you could see nothing at all at this stage. But that will be the view you would get through the head-up display. That's very definitely enough to shoot an approach off. So that's the EVS 3600. A word on the camera location. I'd say the early days of EVS, even on the BBJs. The camera was mounted below the radar and in front of the nose wheel. Well, I'll say the parallax problems sort of reared their head, and that camera got moved there to on top of the radome. That gives the view as close as possible to the pilot's line of sight, makes it more realistic what you're seeing. That unfortunately means that the radome, which is made by Nordam, i.e. the modified radome is made by Nordam, is not interchangeable with a standard one, or indeed easily sourced if a replacement is needed. So if you have bird strike damage on that radome and or for whatever reason you need to replace it, you're going to have to contact Nordam and wait to get one made and shipped out to you. The glide slope antenna within the radomes moved down to accommodate the camera, because that would normally be up at the top behind there. Now the camera itself is protected by a window. So what you're looking at there is the window rather than the lens of the camera. You can just about see the lens of the camera as the circle set several inches back behind that window there. That window isn't just any old window. It's a special one optimized for transmission of infrared wavelengths. It's got its own integrated heating elements and its own heating controller, because obviously, like any window, you don't want it icing up on you or misting up or what have you. And of course, being heated, it gives it a bit of flexibility and bird strike protection. The infrared window heating controller, it's enabled automatically by the HES computer when passing below, descending through 27,000 feet when the EVS is turned on. It's not considered necessary to have it on, at higher altitudes or in the cruise. Just like any anti-ice system, I suppose. And the guidance from the manufacturers is that the EVS system should not be switched on more than 30 minutes before departure to extend the life of the window heating elements. Yep. Now, image display takes around 10 minutes from switching on, so I guess you've got to time it as being between 10 and 30 minutes before departure. I would imagine that this is because the heating of it, if it's left on for long periods on the ground, particularly in hot climates, could cause the various components to fail. So they recommend putting it on between 10 and 30 minutes. Electrical power for the EVS system is slightly different. So you can see that the P18 2C row is labelled slightly different. It's labelled head-up display / EVS, and you've got 3 different circuit breakers on there. From the left, you've got EVS cam, which is 28 volt DC for the IR sensor unit, which is what they call the camera. The infrared window heater power is 115 volt AC for the IR window, and then the controller for the heater is 28 volt DC. All 3 power sources are taken directly from the aircraft buses, but are controlled by the HGS computer itself. So they effectively all pass through the HGS computer. There is a yoke switch to toggle the EVS video on and off on the combiner. A short press of that will just switch it on and off. A long press will dim the image to a preset level, and according to the MEL, that yoke switch has got to be operative, otherwise you've got to deactivate the whole EVS system, so that it isn't cluttering your view when you don't need it. EVS equipped aircraft have got a contrast control in addition to a brightness control next to the knob on the combiner. So again, that's another easy way to spot whether your aircraft's got EVS or not. And there are extra functions in the McDo to cater for EVS. So from the main menu, you select HGS, go HGS modes or data, and there'll be an EVS prompt down there at 6 right. That takes you to the HGS EVS pages. You've got at the top of the list the ISU status. So remember, this is the infrared sensor unit. That's what the camera in plain English. On or off. It's used to switch the whole EVS system on or off. So it's not the same as the yoke switch, which is only controlling whether the image is displayed on the combiner. This ISU status on off actually will shut down or waken up the whole EVS system. So it activates or deactivates both the infrared sensor unit and the infrared window heat controller. Now, a word on that infrared sensor unit. I spoke earlier about the theory of it, and it's sensing heat, radiated heat. Well, in order to do that from the very low levels of heat that objects give off, it's the whole unit, the camera unit, it's got a cryogenic cooler that reduces its running temperature down to an incredible minus 196 degrees centigrade. And it does this to reduce thermal noise on the image. Now, thermal noise, for those of you not come across this phenomenon, is a sort of background ambient noise which appears on any imagery, visual and thermal, particularly those of long exposure or high ISO for the photographers out there. I mean, one of my hobbies is astrophotography, and I do long exposure images of 20 to 40 minutes at times, and there's a lot of you can get a lot of noise on there. So what you do is you cool the cameras to reduce that noise and that sort of browning motion of the molecules, and that gives you a clearer image. So this is tried and tested technology. Say advanced astronomical telescopes use it. Telescopes out in space use it. Cooling cameras is a known thing, a mature technology, and that's what's done here to get the internal temperatures down to those very low temperatures to give you a better image on your display. Now, that cooling process and return to ambient temperature after use put a strain on the cooler and the components within it. I mean, you can imagine most things, if they cool down to 196 degrees centigrade, would get fairly brittle after a few cycles. So to help extend the life of the cooler and the components, the manufacturer recommends leaving the EVS on if it's intended to be used again within 3 to 4 hours. So that's just about being kind to your equipment. Okay, next item down is display calibration, and the display is actually calibrated automatically as part of the EVS startup process, and again at 2,000 feet or descending through 2,000 feet on the approach if the runway elevation set. Now that calibration, typical aviation comes up with another acronym. We call it calibration, they call it non-uniformity correction calibration. What it does is it ensures that the display is even, of even contrast across. So this if you press this button, this selection on the McDo, then you will initiate a NUC, a non-uniformity correction calibration, on demand for whatever reason you want. If you notice the display becoming degraded or poor or any anomaly, not as good as it was when you switched it on, then go into the menus, hit cal, and in 40 seconds you'll have a cleaned up image again. When that's in progress, you get a cal capture with a countdown timer below where it says EVS on up there on the HUD. Even though it's a 40-second process, or less than 40 seconds, the countdown timer only counts down from 5 to 1. I'm sure there's logic there somewhere, but it beats me. And there is a maintenance option. I haven't actually got a photo of the EVS maintenance page, but it's not actually that interesting. All it does is it aligns the image on the combiner. So you've got vertical and horizontal align and gain adjustments on that page there, just to get it centered nicely on the display. Okay, so you will recall this from earlier on, the component summary. This was for HGS only. If I now add to that the EVS components, so this component summary with EVS, the changes are as follows. You've got a slightly different, well, all the HGS pages are slightly different on the McDo with an EVS prompt. The circuit breakers are different labeling, different functions on there. But again, they all feed through to the HGS computer for onward distribution. The aircraft sensors now include the IR sensor unit, which is that camera on the nose, on the upper part of the radome, and of course the big thing, we've got the EVS overlay on the combiner. So that's it. That's your that's the full component summary with an EVS system. It is not, however, quite the end of the story. We've got more acronyms for you. We've got SVS, which is synthetic vision, and EFVS, which is enhanced flight vision systems. So a quick word about those. Synthetic vision systems displays a computer-generated image. So there are no cameras with this, and this picture is taken from I think this was Universal Avionics. Yes, it was Universal Avionics flight deck for a Classic. So I think this was actually a 737-500 from memory that they decked it out on. I don't know how many of these they sold. I don't know how popular it was. But certainly there was at least one aircraft with it on. It was available as a retrofit for all the classics, the 3, 4, 500 series, and it displays an egocentric view, i.e. a 3D view of the train ahead, as if the pilot was looking out the flight deck window on the PFD, and an exocentric view, so 3D view of the aircraft with respect to the flight plan and surrounding terrain on the ND. So two different displays on there. Now, the systems which combine both EVS, Enhanced Flight Vision System, and Synthetic Vision System are referred to as an Enhanced Flight Vision System. There are actually a couple of different definitions of EFVS. This is the one I'm going with. I know some people or some agencies say EFVS is simply EVS on a head-up display. I don't go with that. I think it's certainly the sources I've seen say it's the combination of EVS and FVS is required to have a true EFVS. Anyway, whatever it is, as long as we all know what we're talking about, this is it. So the upper photo is just SVS, and that's showing the train. That is modelled from an internal database within the computer. That is not real world imagery. I say it's from a computer generated model. It's the same thing you get on a level 3, level 4 full motion flight simulator. That's your train database. The lower image has got EVS superimposed on it, so it's the same view, but as you can see, you've got runway, taxiways, trees, all those other things on there. That's your true EFVS. So and this system is produced by Universal Avionics, who are the same folk that we saw previously with that SVS system for the classics. And they are, I've written here, in the process of certifying. I don't know if they've actually got the STC on this yet. They may have, they may not have, I'm not quite sure, but it's imminent if they haven't already got it. And they call it Clear Vision. That's their trade name for that. And this will be for the BBJ. In their words, the Clear Vision on the NG encompasses synthetic vision system and enhanced vision systems with a user-controlled combined vision system to show SVS and EVS on head wearable displays by both pilots. Yeah, head wearable displays. Let me show you. There you go. So to use this system, you will wear a helmet as shown in that bottom picture there. So let me take you through it. The Clearview installation includes dual Skylens head wearable displays. So that's dual, so that means you both got one. The captain and the FO potentially wearing this, and a single EVS 5000 multispectral camera. That's the camera in the upper photo there. Now, so I haven't seen detailed specifications of this, but it looks to me like it's got 4 cameras in there, 3 in the left-hand window and a single one in the right-hand window. So multispectral certainly seems to be what it is. Each camera, I would suggest, will be optimized for different parts of the IR or visible spectrum, to build up an image which I would imagine will be far superior to the existing technology on the EVS 3600. Certainly it should be if it's using 4 cameras instead of 1, but I don't know. I'm surmising. The solution, marketed as Airwear, not to be confused with the Dr. Martens boots, is the result of a partnership with AirSail Corporation. AirSail provided the prototype aircraft and led the engineering, design, modification, installation and the necessary certification flights. Final FAA STC approval is currently pending, and that's of the time that I made this video. If you're watching this in the future, I made this video in June 2022. So things could have moved on. Well, things undoubtedly will move on. United Avionics, Universal Avionics high-resolution EVS 5000 multispectral camera is composed of 6. Oh, there you go. I should have read it. I only counted 4, but apparently 6 sensors for a comprehensive and unprecedented multispectral coverage. When paired with the Sky Lens, it enables EFVS operations to touch down and roll out under FAR 91176 in reported visibility as low as 1,000 feet with a visual advantage of 33% or more. Now, with a visual advantage of 33% or more, is undoubtedly going to lead to reduced minima, even at airports solely equipped with an LED lighting system. So potentially, this could be a real game changer. It certainly looks like technology is improving all the time, and whether we all end up wearing helmets or not in the future, I don't know. Personally, I'm not sure, but who knows what the future holds. Okay, we've mentioned minima. Let me just run through a few minima before just closing this presentation. So, as regards takeoff minima in Europe, and again, I apologise to anybody watching this in the States or Brazil or other areas of the world, but certainly in Europe, if operating the 737 without the hood and the operator is Cat 2 approved, the minimum RVR for takeoff is 125 meters or a 90 meter visual segment. If you've have an approved HGS and runway protection and facilities equivalent to Cat 3 landing operations are available, the takeoff RVR can be reduced to 75 meters, and that is an extract from a standard minima page for takeoff, and note 2 down there, approved operators with approved guidance system, you can go down to 75 meters. Again, please check your company policy for details for all of this. RNAV minima, lower minima is, now I've written often available. It isn't always available. It depends on the country, the certifying authority, and the approach on a whole range of things. But it's often available for hood-equipped aircraft if full approach lighting is available. And again, check the notes on the bottom of the minima page there, and you can see LNAV, VNAV, normal minima RVR 750 meters. If you've got the full range of lights and a hood, you can go down to 600 meters RVR. Cat 1 minima, so for Cat 1 and lower than standard, they're often published with credit for EVS aircraft to give lower minima. However, not all 737s with EVS are approved for this concession. It depends on the model and combination of the HGS and EVS. So check your company policy for details on what minima you should use. But you can see here, lower than standard Cat 1, it's 480 feet or 480 meters or 350 meters with EVS. Cat 2-3 minima, again, as an approved operator with HGS, you can hand fly Cat 3 air approaches down to standard minimum of 200 meters or 50 feet DH. Hand flown Cat 3B is not approved. Again, it's worth noting for many 737s with HGS and EVS, the EVS is not certified for Cat 2 or Cat 3A landings and is to be turned off for such operations. But again, this information's as of 2022, as per your airline SOPs and your regulatory authority. So check your airline's rules on it. I'm including these slides in here just to give you a flavour of what can be available. So, to summarise, the minima are slightly reduced for HUD operations, but as the HUD systems continue to improve, and by that I mean probably EVS and EFVS, and the regulations start to catch up, it's entirely possible that regulators will be allowing lower minima in the future. EASA, for instance, will be publishing new rules in AirOps Subpart E from the end of October 2022, which should give operational credit for EVS, and it's expected to reduce RVR minima by not more than a third. So there are gains to be had with it. Whether they're enough or not, it's probably not for me to say. So, to summarise with HUDs, and this is the last slide on the subject. Here's my take on HUDs, because a lot of people ask, are they worth it? Is it something, is it a must-have? And I say I've been fleet manager, tech captain at an airline where we had head-up display in our 737 fleet. You can see my ugly mug there at the bottom right. So it is a fact that many operators that have a HUD fitted to their 737 fleet never use it. Now some have even deactivated it or removed it, and that photo on the upper right there shows an airline that has removed the HUD from their 737. That's a blanking panel there, just above those eyebrow windows. They got the aircraft delivered with HUD, found they never used it, had it deactivated for a while, and then eventually they just said, "Oh, blow this, we'll take the thing out," and they removed it. Now, like any equipment, if you're going to use it, you need to be trained on it. And the fact is that there are very few simulators in the world with HUDs. So it's very difficult to train it, to train the use of it. I mean, you could argue that one-off training may be okay for just using it in normal line ops, but I would suggest that for doing LVP approaches, a similar level of training needs to be had that we do for LVB approaches with autolands. So a certain number of approaches per year in the sim and out on the line. That is never going to happen if the simulators don't have HUDs. So it's actually quite difficult to keep crews current at LVP ops with the HUD. If they're not current, then can you really use the lower minima? Would you want your crew using the lower minima? So really, it's coming down to is it practical? Are the gains really there? Now the manufacturers will point to the slightly reduced minima and suggest that there may be a cost saving associated with the reduced number of diversions because of those reduced minima. But I think that an aircraft that's already Cat 3A or some aircraft with the rudder channel Cat 3B capable, the benefits are really quite small at present. In the future, who's to say? But at the moment, when we've got an aircraft which can auto land without a HUD, do we really need a HUD? Perhaps the biggest benefit, I would suggest, is the more intangible one of flight safety. Now, RSAT and tail strike warnings are obvious examples, but without a doubt, situational awareness is surely enhanced with a HUD, because your eyes out, especially a HUD with EVS, particularly if you're near the ground. Now the cost benefit for this is very, very difficult to quantify, especially at a list price of $140,000 per tail per aircraft. So HUD really, in my view, remains a luxury which is difficult to justify on financial grounds, but it may just give a crew the capacity to prevent an accident, and that, of course, is potentially priceless. That's it. That is everything I know about the head-up display. If, as always, you've enjoyed this video, please give it a like, a subscribe to my channel, and share it amongst your colleagues. Don't forget, all this information is available in my book, The 737 Tech Guide, and you can find links to that from my website. Thank you all very much for listening.